Yeah, so welcome again to Management Decision and Control by Samuel Evander. We are here to do some revision, and today we want to look at linear programming, more specifically the Simplex Tableau method. And to guide our discussion, we are going to use a question in the CPA paper of October 2021. And the question is, I think, the last question in this paper. So we're just going to first conceptualize information and then see how we can be able to find different solutions. But before I go into, I just want to give an overview of linear programming. Now, linear programming is an important, of course, tool in helping different organizations find optimal solutions for decision making. And one of the things that we understand that businesses do exist to maximize profits and minimize costs. So linear programming helps us to come into the picture to give us the best combination or the best solution for all our constraints to enable us either maximize profits or minimize losses. So businesses, of course, work in resource constrained environments. Businesses cannot, they don't have infinity on their operations. And this could be maybe terms of their space. They have a limited space. They have maybe a limited number of hours of their machine hours. There are many limitations that come to serving the market. So the organizations have to make the best, they have to choose the optimal combination between the different variables for them to be able to make key decisions. So linear programming has two methods, and we have the graphical and then the simplex method. Now, the graphical is mostly applied where we have two variables, and that is X and Y. So because X and Y can be plotted on, let's say on the graph paper, then we can be able to leverage on that and determine. But now it gets complicated where we have more than two variables, because we don't have the graph giving us that platform to be able to calculate what you would, our optimal solution. So then we borrow the whole idea of the simplex method, which borrows the concept of matrices. So we have aspects of matrices, and then we go ahead to look at aspects of slack variables and so on. So you find yourself circumstances where you have to work towards a given, of course, you translate the information I've given you into equations or functions, and then from those functions, you're able to put them in a matrix format, and then you're able to find your optimal solution. Actually, one of the there is just one of the past exams where they gave you the tableau, and in this case, they were asking you to interpret the tableau. So the examiner can approach it from many cases, either give you information and then you determine the tableau, or they have to say, give you already the tableau, and then you just do the interpretation at hand. So we have this question, question 5. Let's just try to go through and see how we can conceptualize information and see how we can put that on paper, as I can continue explaining on what you need to do exactly. So we know very well that they're telling us that Golden Doctors Clinic, GDC, was established by two specialists in Kampala. And to handle complicated cases of diabetes, hypertension, stroke, blood clots, and other neurological disorders. GDC has two categories of patients. That is grade 1 patient suffering from diabetes, hypertension, and minor neurological disorders. And we have grade 2 patients who are suffering from stroke, blood clots, and major neurological disorders. GDC's motto is to save life profitably, which motivates the owner, doctors, to always investigate the loss-making grade of patients, since they employ fellow specialist doctors on part-time. They also plan to add on a third category of cancer patients for treatment and palliative care. One of the doctors also considered that a continued skills development is key to providing satisfactory services to clients. She wants to have quarterly targets on both skill development and client satisfaction. The accountant advised her that these targets could be evaluated using the Balance Scorecard performance tool. The owner doctors also know GDC's weekly maximum profit before sanctioning measure investments in introduction and third category for cancer payments. GDC makes a profit of 40,000 and shillings 50,000 per patient for grade 1 and grade 2 respectively. And they go ahead to say doctors and laboratory technicians can provide 150 hours and 30 hours respectively in a week. Now, one of the things that as we read through our text, we need to start conceptualizing what are some of the variables that Golden has, and also aspects of what are some of, let's say, limitations, constraints to these different variables. So as we can see here, the first thing they're telling us, they have given us the profit, and definitely one of the things that you get to realize is that Golden exists to make profits, to maximize profits. So they have given us what is the profit currently for grade 1 and grade 2 respectively. So we want to see what fits into that. So they proceed to tell us that doctors and laboratory technicians can provide 150 hours and 30 respectively within the week. The pharmacy that supplies drugs to GDC can only supply 750 grams of the required drugs in a week. So you can see this is also a constraint in its own. They can only supply 750. So no matter the demand, this is one of the other constraints that we have. And then they are telling us that our grade 1 patients require 25 grams of drugs and 2.5 hours of doctor's time in a week. Grade 2 requires 15 grams of drugs and 4 hours of doctor's time in a week. Remember, we have 150 hours for the doctor and lab technician. We have 30 hours, and already they are telling us here of how much grade 1 and grade 2 requires of the doctor's time. It is only grade 1 patients that need services of a GDC laboratory technician, and each patient requires 1.5 hours in a week. So they're telling us that you are the accountant of GDC. The owner doctors have instructed you to determine the weekly maximum profit. And they're asking you to use linear programming to advise GDC owners on the number of patients that maximizes their weekly profits. And then they're asking you determine the redundant and scarce resources available in the week. So that is also something that you need to determine. And then they also want us to describe how BCS, the Balance Scorecard tool, can be used to evaluate skills development and client satisfaction targets. So those are the three things that we need to look at in this case. Now, like I said, linear programming is usually used where we have constraints, and then we have to determine the best optimal combination of these constraints that can either help us to maximize our profits, but also maybe minimize our losses. So one of the key things that happens when it comes to linear programming, we always have to determine the objective. So from this information, you get to realize that our objective function, or our key objective here is to make profits. So from that perspective, our objective function will be inclined to the aspect of making profits. So that is very important. So we are going to see how to be able to attempt this. So let's see how we can do this. I'll just try to open my work file. So the first key, whenever we're working with linear programming, the first thing that we have to strive to is to translate the information we've been given into, say, functions, into equations, okay? So that is very important. So we are going to use the information we have to translate it into equations, okay? And then from there, we can be able to derive whatever we want to derive. So for us to better change this into the information we want to, we have two products right now, okay? We have two products, and those two products are basically the patients that we serve. So we have grade 1 and grade 2. So I'm going to say, let grade 1 be X and let grade 2 be my Y, because those are the ones, those are the key, basically keyword that we serve. Just a moment. So I'll just say, yeah, I'm looking at the solution. Just increase the size. I'm saying let's grade 1. Let grade 1 be X, and let grade 2 this 2 is this one, be Y. So that's the first thing that I want to basically do. So once I've tried to come up with the equation, so I'm going to come back to my text. And I'm now going to see if I can start making my equations. So let's start right here. So they are telling us that GDC makes weekly profit of 40,000 and 50,000 per patient from grade 1 to grade 2 respectively. Now this is what I'm going to use to write my objective function, okay? Like I said, our role here, whatever objective we have here, is to maximize profits. So we want to see what combination of grade 1 and grade 2 patients gives us a maximum weekly profit. So that's what we are going to basically do. So translating this into whatever I have, I'm going to come here. So I'm going to say objective function, which I'm trying to write. So I'm going to use the analogy of what I've written there. So since they have told me that I have a profit of 40,000 on grade 1, so I'm just going to say 40,000 of grade 1 patients, of my grade 1 patients. So here, let me use X since I've already included that. So 40,000 X plus, they also gave me 50,000 for grade B. So I'm going to include that 50,000 Y. Now, this is to give me a profit, which I'm going to use as P. Okay. So for me to determine the profit, it will be the number of units of grade 1 patients plus 50,000 times the number of clients for grade 2. And that will give me my weekly profit, which I'm depicting by the word P. So if I want to, basically what I'm trying to do here, my function, or what I want to do, remember, I told you we want to maximize profits. Our objective is to maximize profits. So maximizing our profits, P, ideally will now be given by our function, okay? Which we are saying is, let me write it here, is 40,000 X plus 50,000 Y, okay? That is what we are trying to do. So that is the first thing that I'm doing. Now, once we have that, we're now going back to our question and see if we can get any other function, okay? That's our objective function. So coming back here, we've now made sense of this information. Sometimes they could be costs. They may tell you this is what they want to save in terms of costs, so that they will be able to give you that. But since we have been given profit, sometimes they can also give you contribution. Instead of profits, they can give you in terms of what contribution each of the products brings in. And then they can be able to ask you something that maximizes the contribution. Like I said, our objective function is usually determined by what is management aiming at. So you can say here, they want something that maximizes the weekly profit. So that is why we have used as that as objective function. So the next thing we're going to do is come here and try to look at this other more information. They have told us that doctors and laboratory technicians can provide 150 hours and 30 hours respectively in a week. The pharmacy that supplies drugs to GDC can only supply 7,650 drugs of the required drugs by the patients. Now, this statement is going to help us create equations. We are also going to be able to leverage on this again, where they're telling us that grade 1 requires 25 grams of drugs, okay? So the next thing we are going to do is we are going to first, let's look at the doctor's time. So doctor's time, they have told us that 2.5 hours of doctor's time is required for grade 1, and 4 hours is required for grade 2. They have also given us the one for drugs, okay? Where 25 grams of drugs is required for grade 1, and this is, but remember we have a maximum of 750. So how to translate that into our equation? I'll just come here. So I'm going to look at drugs as the first. So remember, I've already denoted X to be my grade 1 and Y to be my grade 2. So we have said that now our grade 1, which is our X, okay? They are telling us that it requires, it requires 25 drugs. So this one requires 25 drugs. And our grade 2, this is grade 2, which is Y. okay, requires, in terms of drugs, it requires 15 drugs. Okay, each patient, okay? Each patient requires 15 that. But then they have also told us of what is maximum. So maximum supply is 750. And these are in kgs. So if this is the information we have on drugs, means that in one or the other, we have to find how we fit within the 750. No matter the number of clients we have to fit within our constraint, which is 750. So remember, this is per each what? 25 is per each client, and 15. Okay, 25 is per each client of X and 15 is per each client of Y. So for us to derive that this constraint into an equation, it will be basically be 25x. Okay, so 25 is the number of kgs that are required for each patient. So 25 times the number of grade 1. Okay, maybe I could just add something here. Let the number of clients for grade 1 be X. So when you multiply 25 times the number of patients for X, okay, gives you the total number of drugs that we need for patients of grade 1, plus 15 times Y. So Y is the number of patients that we need to serve under grade 2. So when you multiply by 15, which is the required kgs of drugs for each patient of grade 2, then that will give you the total kgs of drugs that we need for a patient under that category. And this will equal to, now, this has to not be more than 750 because our maximum supply is 750. So when you add the total number of kgs of drugs for X added to that of Y, when you add the two together, it should not be more than 750. So it should be less or equal to, it should be less or equal to, okay? So I'm going to use my sign here. So less or equal to, this gives me, so less or equal to 750. So that's how my equation will be. 25x plus 15y less or equal to 750, because we must not exceed this. If we are planning for our patients, we must not exceed the 750 kgs that we have in terms of the supply that is required in a week. So that's what they have told us. One of the things that you need to take into consideration, as you can see, they have given us in a week, and even what we are looking for is for in a week. So just the examiner wanted to bring in a confusion where they give you something daily, then you have to translate it into a week, or if they give you something monthly, then you have to bring it back down to a week. But most of the information they have given us is into a week. So that is one area of the drug. Let's look at the one of the doctors. So we are going to first look at the category of the doctor's time hours. So the doctors can only provide up to 150 hours. So it means that the grade 1 and grade 2 patients have to fit within the 150 hours. So what we are going to basically do, the other side, is I'm going to get what each hour of a patient requires under grade 1, which is 2.5, and our set time was X, plus what we need for doctor on grade 2, which is 4Y. This should fit within the number of hours that are available for the doctors. Okay, that should fit in within the number of hours that are available for the doctors. Let's first look at the doctor and then come back for the for our technician. So this is for doctor's hour. So for the doctor's hours, just note this, grade 1, grade 2. So we have 2.5. These are hours. And then we have we have 4. Okay. Now we have the maximum supply of the doctor's hours, which is to the tune of 150. Tune of 150. So what that means is our equation will be, our equation or function is going to be 2.5 x plus 4y. Now this, when you get the answer there, should fit within, it should fit within what we have as our maximum. So it should be less or equal 150. So that is what we should be able to have. So that is the scenario. That is how our constraint is. So the next thing I'm going to look at is the technician's hour. Technicians. Okay. So let's see grade 1 and grade 2. So when it comes to technician's hour, they have told us that one grade does not require the services of a technician. So we're going to see how that comes in. So they're telling us that it is only grade 1 that needs services of a GDC laboratory technician. And each patient requires 1.5 hours in a week. It requires 1.5 hours in a week. So I'm going to do that, and then means grade 2 does not require. So I'll just come here. But also before that, we need to understand that the technicians can only provide up to 30 hours. Okay, so we cannot take on more than that. So just come here. Maximum supply is 30 at hand. Then grade 1 requires 1.5, and this requires 0. So our function will basically be, our function is going to be 1.5x, of course, plus 0, which gives you 0, should be less or equal, 30. Should be less or equal 30. So that is what we basically do have. 1.5 should be less or equal to 30. So you go back to your question and see, do you have any other variables that you need to look at? And for this question, we seem to have been able to utilize all the information that we need at hand. So if that is the case, we now go ahead to just arrange our functions But one of the things that you need to realize is that we basically want to, after determining our functions, okay, we want to arrange them and then be able to go ahead to determine our different X and Y. So basically what we're trying to do is maximize profits, okay? And I'll just pick this as it is. Maximize our profits. So this is the function. Okay. But this is subject to the following constraints. Subject to the following constraints. So the first constraint is this. That is the first constraint, and this is for drugs. So here I'm just trying to summarize. Drugs. Now, we are going to work with, okay, let me first finish and then I explain that. So the next one is the doctor's hour. So the doctor's hour, our equation is this. And then the next one is the technician's hour. Which we have gotten as this, okay? So that is what we basically do have. So what I was trying to explain that we can, since we have these are equations, we can modify these equations to simplistic terms, okay? A case in example, when it comes to this equation, we can simplify it since most of these numbers are multiples of 5, okay? 25 is a multiple of 5, 15 is a multiple of 5, 750 is a multiple of 5. So we can divide 5 across, and this can simplify to become 5x plus 3y. Okay. Still should be this is mathematically true. So this should be the same thing. When you get 750 divided by 5 gives you 150. So it should be less or equal to 150. The reason why we simplify this is because we are going to get to a table. We're going to arrange this into a matrix, and we want to work with simpler figures, but it doesn't cost you if you proceed with the same figures, you'll still be able to derive the same answer. This one has points, so we can see, let me see if we can divide 150 divided by 2.5, if we can get something. Okay, we actually get 60. We get 60 net. So I can also simplify this where you can divide by 2.5. So this will be x. This will be x plus, okay, 4 divided by 2.5, 4 divided by 2.5. I think this is, oh, okay, 4 is not a factor of 2.5. So it takes me back to point. So it does not save me anything. Okay, so I'll leave this one the way it is because it doesn't save me anything, because I'll still have points. When I divide 4 divided by 2.5, I'll still have points. So this one I'll leave it the way it is, but you can see 1.5 and 30 have a common factor into them, and that is 1.5 itself. When you divide 30 divided by 1.5 gives you 20. So this is the same thing as X should be less or equal to 20. Like that. So I just wanted to simplify them in that way for you, okay? So if we have that, now one of the things that we also do is we have what we call the non-negativity function. Non-negativity, what it basically means is we cannot have negative patients. So X and Y cannot be negative. So we say X and Y, X, Y should be greater or equal to 0. So we should never have anything like a negative patient or whatever, because these are humans, so it cannot be negative. So this should be that. So this is one of the other constraints that we're looking at, okay? So X and Y should be greater or equal to 0. So this is the function we have. Now from there, we go to add what we call slack variables. We add what we call slack variables. Now, slack variables basically help us remove this less or equal. So slack variables cover up for what you might call any constraint that may not be used at that time of optimality. So they best cater for the excess capacity that might be on a constraint, okay? So that is one of the things that we do. So we introduce slack variables on each constraint at hand, okay? So here, now what we shall say, since we're introducing slack variables, now these can be in different formats. Now, let's say, let's use A. Let A be the number of unused drugs, okay? Let A be the number of unused drugs, and let B be equal to the number of unused doctor hours. And the next one we have is the technician hours. So we shall say, let C be equal to the number of the unused, sorry, I think it's supposed to be unused. The number of unused technician hours. So we're just trying to leave a room, because sometimes when you reach the level of optimality, you can have, you might have some unused hours, okay? Or unused drugs. That is very possible. So let this, technician hours, like that. So after we have done that, then our functions are going to be like this. I want you to observe very critically. So whatever you have as doctor's hours drugs, let's first start with the drugs. Your drugs will be this. Instead of us having this less or equal, we'll have a plus a equaling to 150. So 5x plus 3y plus a is equal to 150. Then for doctor's hours, this will be, I'll just speak it the way it is, 2.5 plus x, let me use small x's and small y's here. This is going to be plus b is equal to 150. Okay, I believe you can be able to relate. And then we are going to look at the last one, which is technician's hours. So we have x less or equal to 20, so it will be x x plus c equaling to 20. That is what we basically have. So we've added our slack variables. So adding slack variables. Okay. So we've added our slack variables. Now, after we have done so, we go ahead to create our initial tableau. Now, one of the things that we also do, we adjust our so-called objective function. So what we are going to basically do, our objective function, which is maximize profits, the objective function, which is P is equal to this one, we are going to make this equation equal to 0. So this is how it looks like. So what I'm going to basically do, I'm going to bring this 40x this side, 50 this side, so that the function is going to be like this. It's going to be P minus 40,000 x minus 50,000 y is equal to 0. So I'm just trying to change the function so that it can equal to 0. So once I'm done with that, I'm now going to translate that into my tableau. Okay, I'm going to do my so-called tableau. So I just want you to wait and see. So first tableau, it's basically, you can call it a table, okay? But we call it tableau, like that. So we usually have variables. Okay. So the variables we have in this case is x. Okay, x, y. Sorry. Okay, we have x, y. Then we have our so-called slack variables, because I want to basically have my the last I want it to be. So we have from these equations, I think we can see that in addition to this, we have our A, B, and C. Okay, that is basically what we do have. And then after we have looked at that, we also need to appreciate that we have our objective function, which in this case I called P, okay? Because that's what we are actually looking out for. So I'll call it P. So, and then we have, of course, up here, I'm going to again rearrange the same things the same way they are here. So I have X, have Y, I have my so-called A, and then I have my B, I have my C, okay? We shall also have the solution column, P, then we have the solution at hand. So let's just try to distribute this in. So we have the first one, the first equation. We have under X, we have 5, okay? And let's just do this. I'm just trying to put this here, okay? And X, we have 5. Here we have 3. Here we have 1. Okay. This is 0. This is also 0. We also don't have anything of P. So then this will get you to 150. Okay. So that is how we have put that in there. So after you have done that, now we have to proceed, okay? Let's try to put this here. So this will be 2.5. And here we have 4. And here we have 0. Here we have B, we have basically 1. Okay, as we can see there. C, we don't have anything. P, we also don't have. You can actually, for you to simplify your work, it's not mandatory that we should include P here. You can even leave out this P so that we just have, because you always have 0, 0. Then here, I think I picked something wrongly here. Just let me just try to see. Was this 150, 150? Okay, it is the same. I just adjusted. So 150, 150. So the total here, as you can see, is also 150. Then here, technician's hours, which is our third equation, right here, we are going to see that we have 1. Okay. Here we don't have anything. We don't have anything here. But again, we also don't have anything here. We have something here. and this adds to 20. Okay, so I hope you're following how I'm trying to input this kind of information. So after we have done that, we'll do the last one, okay, that we are looking at. So from what we have, we have this other last equation of P. So this P is basically what you would call your so-called solution, okay? And if you to remember from what we are trying to look at, that P, we actually got it from here, from this statement. So that is what basically you need to utilize. So P is the solution, is the objective function at hand. So when you come to your W here, what you basically do is come and write. Now, for the first equation, under X, we have negative 40X, okay? So here we have negative 40,000. Under Y, we have negative 50,000, okay? And we don't have any A, we don't have any B, we don't have any C, okay? And what do we have in terms of solution for this equation? Is actually a 0. Is a 0. So that is what we basically do have there. Okay. But anyway, I tried to exclude here on this, in this equation, only what we have is a P. So what I'll just do, let me actually leave out the P here, so that I just do this 0, 0, 0, 0, and do a 1 there, so that I represent the P. So this is what I basically do have. So I'll just pick this and bring it down here. So you can see that this is in terms of, it's more of like a matrix, okay? This is more of a matrix. Now, when you have this first W, the next thing you're going to do is look at the W and choose what has the higher negative. So the higher negative is actually at this point. This is the column that has the higher negative, this one. So if it's the one that has the higher negative, it is going to give you your pivot column. Your pivot column. So after getting the pivot column being 50, because we're saying that we choose the higher negative, which is this, we then go ahead to choose our pivot row, basically the row that we are going to use, because we want to get the pivot point. Now, I want you to look critically. So what we are going to basically do is we are going to divide this divided by this column. So 150 divided by 3 gives you 50. 150 divided by 4 gives you 37.5. Okay. And of course, when you divide your 20 divided by 0, that gives you that is something that is very huge. Okay. So it gives you infinity. So our goal is to select one that gives us a lower figure. Our goal is to select one that gives us a lower figure. So we can see that this has given us 37.5. So this should be our pivot point. I repeat, once you're trying to select, once you have your first W here, as we have put it, the next thing you have to look at the higher negative, okay? So the higher negative is negative 50,000. And after getting the higher negative, that will give you the column, get the solutions this side and divide by each respectively. 150 divided by 3, you get 50. 150 divided by 4 gives you 37.5. 20 divided by 0 gives you infinity. Okay. It's basically gives you infinity. So it's more. So 0 divided, of course, you're not looking at, because this is a section on its own. This is a solution, and when you have, let's say you're using your writing, you put basically this this mark here, just to show that at the bottom is basically a solution part. So all we are looking at are these 3 lines. Okay, all we are looking at are those 3 lines. So once we have determined that it's 4 that gives us a lower, our aim is to strive to make this 4, we have to make it a 1. We have to strive to make that 4 a 1. Okay. And we also have to make sure, okay, later on, we have to make sure that whatever is above it will be 0, and whatever will be below it will also be. Now here we already have it 0. So this one will also become 0 at one point in time. But let's first deal with this. Let's see how our table looks like. So this will remain the same. This will be our first table. So this, for the first time, it's going to be the same. Let me first put it there. So we want to get this to become 1. And what we are going to basically do is we have to divide all through by 4. So we have to divide all through that by 4 if we are to come to 1. Okay. So what that means is that our second column this will be 2.5. You press that on your calculator, divide by 4. That will give you 0.6. Okay, 0.625. This will give you 1, since 4 divided by 4 is 1. 0 divided by 4 is 0. 1 divided by 4 is 0.25. So this is 0.25. Then 0 divided by 4 is 0, 0. And this 150 divided by 4 will give you a 37.5. So I'll keep this and put it the way it is. And remember, this one also remain the way it is there. So this is the second W. Second table. So the next thing I'm going to do is to make sure that since I already have this one as 0, well and good. Now I have to strive to make this also 0. So what that will be, I'm going to do third table. So I'll just pick my heading to be the same. Now, I'm striving to make this 0. Now, I have to do this as a function of this pivot row, okay? So for me to find my new row, okay? This row, this is row 1, okay? So row 1 will equal to 3, okay? Because I want to make it 0. So since I already have 3 there, so it's going to be, for me to determine my new row, okay, it will be going to be basically row 1, which is the 3, minus 3 row 2. Now look at this. If this is 3 and I subtract 3 times 1 to give me a 0. Let's see it from here. 5 minus 3 times this. So it's basically 5 minus 3 times this gives me a 3.125. This is 3 minus 3 times 1 because my row here is 1. So this will give me 0. And then this one here, this is 1. So it will be basically 1 minus 3 times 0 because here is 0. The row 2 here is 0 times 0. So it will give you 1. Then the next one is 0 minus 3 times 0.25. 0.25 gives me negative 0.75. This one is 0 minus 3 times 0 gives me a 0. Same story here, gives me a 0. Now this one, let's see what it's going to be. It's going to be 150 minus 3 times 37.5. Gives me a 37.5 as well. So I've been able to gain a 0 here that this was my aim. Remember, my aim was this to become a 0. So these other columns will come back the way they are. So I'll just bring my columns the way they are right there. This one, now see, if I had a number here, I would also strive to make this a 0. But since I already have a 0 here, I'll just leave it the way it is. I'll bring it here. Okay. Now, I also have, remember, there's a 50,000 there, okay? There's a 50,000 there. All right, sorry. Been logged out. Just to reshare what I was looking at. I was here. So I was trying to explain that after we have written this here, because it already has a 0 at the start, what I'm going to strive to is to also make this one 0. This one, everything that is below this pivot point needs to be 0, just like what is above. So since I already have a 0 here, I've just written this here, but now I'm going to determine this. Now, remember this is my row 2. This is row 2 as is. This is row 3. And this is row 4. Now my row 4 is going to be, remember I used the 50,000 to dictate. So it's going to be what is already there, negative 50,000, okay, plus 50,000 row 2. No, actually, leave out this. Just say it's going to be row 4, the old row 4, this 50,000, negative 50,000. You don't have to write it because you're going to apply this on every column. So R4 plus a positive 50,000 R, because this is negative 50,000. So what can be added here is a 50,000, which is the 50,000 R2, because R2 is 1. When you multiply it by 50,000, you come to 0. So let's see how that comes. So let's start here. So this is 40,000. So it will be 40,000, negative 40,000 plus 50,000 times what is on row 2, 0.625. Okay, I think that is what we basically do have. And I hope you're trying to pick something here. So let's see. So we get negative 8750. That is what we basically do have. So this will give us a 0 because it will be, you can just test it, negative 50,000 plus 50,000 times 1. Basically gives us a 0, and that was our aim. Our aim was to get a 0 here. So let's try out this and see. So remember, here we have 0, 0. So definitely the answer is 0 because it will be 0, which is down here, plus 50,000 times 0. So you come to 0. You come to 0. Let's try here. Now here it will be 0, which we have at the bottom, plus 50,000 times the 0.25. 0.25. So it gives us 12,500. That is what it basically gives us, 12,800. Now this right there. And then the next one is, this is, we have a 0 here. We also have a 0 here. So ideally here, this will also be a 0. Same story, not same story here, no. Here, remember we have, it will be 1 plus 50,000 times 0. I'm just trying to demonstrate this for you, which will be a 1. So that will be 1 automatically. Okay. That's what we have. And then we have let's have here our 0 here. This will be 0. Let's see, this will be 0 plus 50,000 times 37.5. So it gives us 187 that. So that is what we have. So I believe that right now you can try to pick the what we are trying to basically do, the skill. So this is the first thing. So we have been able to determine our pivot point, which was this, and we can see this is the zeros. So once we have done that, now we cannot stop until there is no our objective is to stop when there is no negative at the bottom. That is our objective, to stop when there is basically no negative at the bottom. Okay. Now some people may approach it in a way that their objective is to have all negatives at the bottom. Okay. But the approach we are using is not to have negatives at the bottom. So what we are going to do is we are going to use the same approach. So we are going to still enter from, we pick, remember last time we picked the highest negative. So our highest negative is this one. So this will give us our pivot column. So after we've gotten our pivot column, we are going to divide, okay? So I'm going to divide 37 divided by 3 gives me 12. I'm going to divide this, divide by this, gives me 60. Then I'm going to divide this, divide by this. So this is telling me that the one above, the column above, which is row 1, gives me the lowest value. And remember, we say that we select one that gives us the lowest value, just like the one when we did when we were here, which we chose this column because it gave us that 7.5. So that's the same thing we also do when we come here. We shall select this one, the one that's giving us the 12. So what that means is that my fourth table remember, if we are selecting this as our pivot point, we have to make this one, we have to make that one 1. Okay, that one has to be 1. So we are going to divide our row 1 is equal to row 1 divided by 3.25, 3.125. So we are going to divide across by 3.125. Okay, we are going to divide by 3.125. So we are going to make this 1. So I'll just write this here. So okay, this one is supposed to be down here. So this will be 1. Now this one is 0 divided by 3.125 gives me a 0. This will be 1 divided by 3.125. It's giving us a 0.32. And then this one, negative 0.75 divide by 3.125 gives me a 0.24, negative 0.24. That is what I get. Then when I come to C, this is 0 divide by 3.125 gives me a 0. This also gives me a 0. This also gives me, I'm going to do 37.5 divided by 3.125 gives me a 12. Okay. Now, one of the things that we need to do is you can actually pick this and put it the way it is and move to the next table. Or sometimes maybe to manage time, since it's an examination, you can also go ahead to make this one 0 in the same table so that you don't have to do another table again. You get it, eh? So you can do it all together at the same time. So let's see how this is, because this was our third table. So I can do, instead of rewriting this, because I can rewrite all this information right here, and then I come that I want to start making them 0. So, or else I can make them 0 from here. So what I will do is my row 2, okay, my row 2 has to be 0. So ideally this has to be 0. So for me to get my row 2, it will be already what is existing, row 2, because I need it to be 0, okay, minus 0.625 R1. Remember, R1 has now become 1. So if I pick my current 0.625 here, minus 0.625 times 1, which is my R1 up here, it will give me a 0. So I'll just have my 0 right there like that, okay? Let's see. Now, the next thing I have to do as well, I have to make sure that this one is also 0. So what that happens, okay, let me first finish this row before I can do. So this one will be R1, so it will be R2, it will be the one that is existing, minus 0.625 times 0. So it gives me 1. And this will be 0 minus 0.625 times, remember what I have and under my here is 0.32. So this gives me 0.2. I don't know if you can see what I'm trying to basically do here. So 0.2, then I come here. My R2 existing is 0.25. So 0.25 minus 0.625 times R1, which is negative 0.24. It will give me 0.4. So when I come to here, this one I have 0. My R2 existing is 0. Minus 0.625. This is being multiplied by what? 0.625, 0 minus, this is also 0. So this will be 0 basically. It will be 0. Should be same story here. Now here we have 0 and a 0. Okay, 0 and 0. So this also gives you a 0 when you do the calculation, but you can try it. Then under the solution, I'll just do it. This will be R2, which is 60 minus 0.625 times 12, which is up here. So this gives us a 52. Is it a 52.5? Did I do it right? Let's see. 60. It's not 60. Sorry, it is not 60. I think I was trying to pick this information. It is 37 point. It is this. That is not confuse us. It is 37.5. That's what we have. And our R2 minus 0.625 times the 12. So it gives us 30. It gives us a 30. So let's try this. Now I have been able to get, this is 1, this is 0. This also has to become 0. That one also has to become 0. So how does R3 become 0? R3 will still be equal to the old R3. So R3, which is existing, minus old R3 minus R minus 1 times R1. That is what we basically have. So it's basically R3 minus R1, but just for you to understand the concept. So I'm going to, so this one will become 0 automatically because it will be 1 minus 1 times 1, which gives me a 0. Then when it comes to Y, remember we have our Y, our R3 that is current here is 0, minus R1, which is 0. So this will also still be 0. Let's try this. Idea this is R3 minus R1. So it is basically, remember we have this 0.32, which is our R1. So just get 0 minus 1 times R2, it will give you minus 0.32. When you press your calculator, that's what you should be able to get. Let's look at this. This is R3, which is 0 minus 1 times negative 0.24. So this will give you 0.24 as the answer. If you're trying it out and you don't get it, then you can be able to ask, and then we can try to explain more, but you should be able to get it. So when it comes to here, we have our R3, which is 1 minus 0, because it's 1 minus 1 times 0 gives you 1. So it still remains 1, okay? It still remains 1. Here we have a 0, 0, 0. So this will be 0. And then when it comes to the next one, 30, here they are telling us R3 will equal to, remember we have 20 up here. Our old R3 is this, minus R1, which is 12, or 1 times 12, which is gives you 8. So that is what you basically have. So you've gotten 0 here. Now what you don't have is a 0 here. You have to get a 0 here, you have to get a 0 here, you have to get a 0 here. Okay? So for us to get row 4, a 0, this is what we are going to do. We are going to get the current R4 which in this case here it is negative 87750. So the old R4, okay, plus 8750 R1. Now, as you can see, all these other rows that I'm finding, they need to be a function of R, of the pivot row. That's why I'm using R1. I've used R1. I've used R1 here. So they need to factor in R1 when you determine the new row. Okay. So it means that this will be now the old 8750 plus 8750 times 1, because my R1 is 1, which gives me a 0, which is my target. So let me see this. So this is 0 because I have 0 in the old row, plus 8750 times row 1, which is 1, which gives me 8750. Do I get 8750? We can repeat it to 0, which is our last R, plus 8750 R1. Okay. Sorry, here our R1 is actually 0. This is 0. This is not, this is 0. I hope you get what I'm saying. It is this 0 plus 8750 times 0. The one was on or ended on this column. So here we have 0. So we have to consider this. So it is 0 like that. So let's look at this, and then so this is R4, which is 0 plus 8750. This has to be multiplied with your R1, which is this 0.32. So it gives you a 2,800. That is what you're getting. Let's look at this. So this one is our R4, which is 12,500 plus 8750 times negative 0.24. It gives you 1,0400. That is what you basically have. Okay. We proceed. Let's look at this. So this one, we have our R4 to be 0 plus 8750 times 0 gives us a 0. This will also give us a 0 ideally. Let's try out that. Let's try out this. This will be 12. Okay, it will be R4, which is this 1,875,000 plus 8,750. You should be able to press this on your calculator, times the current R1, which is 12. So it gives us a 19,198 that. So that is what we basically have. So once we have this, now remember I say that we only stop when we exhaust the negatives at the bottom. So at this level, we can say that there is no negative at the bottom. And that is true. There is no negative at the bottom. we've been able to exhaust the negatives at the bottom. So it means that this will be our final W, okay? This will be our final W. This is the final. So if that is the case, how do we read this information? Now, wherever you see X, so when you see X, you come down and see where there is 1, and then move to the corner to the solution. That should be the value of X. Get here, do like this. Come to here, and then when you move this other side, gives you 12. So the 12 is actually the value of X. So your X, which were our grade 1 patients, is actually 12. Then let's get Y. Now Y, when you get down here with Y, you can see there is a 1. And then when you move this other direction, it gives you a 30. So your Y, which is basically your grade 2 patients, is basically 30. Now, okay. I need to redo something. Let's just look here a little. We need to do something here. I think I took this to be 0. Now I just want to recalculate this a little because it should be it should not be 0. So we said that our R4 here, our R4 is the old R4, which is 1 plus 8,750 times the 0 here. So this should not give us a 0. This should give us 1. And if it gives us 1, it means that P, when you get to P and come down, your P is this. But before P, let me just do, now wherever you see that we have A and we don't have any 1, those will be regarded to be zeros. So A is 0. So A, which was the slack variable for, I think, drugs, is 0. B is also 0 because there is no 1 under B. This is 0. C is actually 8. You come down here and go, this is 8. So C is actually 8. C is the slack variable attributed to technician's hours. Then P, when you do P and get here, is P is 1. Your P is 1,980,000. Now what was P? P was the maximum. Remember, P was the profit that maximizes. Okay, it was because the profit that the maximum profit, the weekly maximum profit. And if you remember what the examiner asked us, when you go back to our question, the examiner told us to determine, when you go down here, the examiner asked us to use Simplex method of linear programming to advise GDC owners on the number of patients that maximize the weekly profit. So the number of patients that maximizes the weekly profits is grade 1 should be 12 and grade 2 should be 30. So you're able to note that down. And the maximum profit is actually this is 1,980. So 1,980,000 is the maximum profit at hand. That is how we calculated. Now, the examiner also went ahead to ask you something here. They asked you the redundant and scarce resources available in the week. The redundant and scarce resources available in the week. Now, what you need to basically understand with the redundancy, remember we've calculated our C, which C was this C. This C was the slack variable under technician's hours. And we say that a slack variable is introduced on a function to cater for or to account for any constraint that might go unused at the point of maximization or optimality. So C that we have gotten, which is the number of hours under labor technician, this is our spare capacity, okay? Basically what you can call the redundancy. The 8 hours, this C, which is equal to 8 hours. These are 8 hours of the lab technician, okay? Which are under redundancy in a week, okay? Which are under redundancy in the week. So this is what you needed to do to give. Now, one of the things that you need to understand is when it comes to doctors' hours and drugs, remember from our table here, we basically got our A to be 0 because we didn't get a 1 here and we didn't get a 1 here. So we regarded those to be. So we ideally don't have redundancy under doctors' hours and drugs, okay? So what you may call it, we call it a dual prices, okay? So not having any scarce time here means, okay, not having any 0 on each of them means that those two sections are scarce in nature. There's no redundancy. There's no redundancy in drugs. There's also no redundancy in the aspect of doctors' hours. So the 2,800 and the 10,400, we regard them as dual prices. Dual prices. Basically, the prices for doctor's time and the drug supply at within the week, because these are scarce resources. So that is what it exactly happens. So that is what the examiner basically needed in this case when it comes to this section. So I hope that you can be able to get anything here. Any questions? Justin, you're one of those that had challenges on this area. Is this better? I don't know if it was Idibu or Henry also had an issue, but those that have attended this lively, is this something that you can relate to? Any questions? Yes, Henry.
No, it means to confirm that at least I've followed this, and if I create any more few minutes to just go through and see how I've been applying the rows with the figures, then it would be good for me to go.
Okay, that is fine. That's okay. Yeah, that is fine. So I believe you've been taking some screenshots anyway of this, so you've been writing down, so you can be able to go back and try it out and also try to look at other questions and we see. How about Justin?
I've also understood the concept, so I'll just try out other questions, then all will be fine.
Okay, fine, Kali. All the best at that. So the other part of the question was asking us about the balance scorecard. The balance scorecard is one of those components that are within the last topic, that is cost management and strategic cost and strategic management. So just briefly, before we can close, the balance scorecard was come up with because of the inefficiencies of other performance measurements. So most people use the financial performance. If you hear a company that is making 2 trillion, maybe shillings in profits in Uganda, then from there you can say that that company is doing well. But then you get to realize that companies should not only be measured on financial parameters, but they should also be measured on non-financial parameters. So the balance scorecard, because it is a balanced, comes in to give perspectives that are financial and non-financial. So this is a tool that was developed by 2 gentlemen called Kaplan and Norton. And basically, they look at what you may call 4 perspectives of evaluating performance of an organization. So the first perspective they look at is the customer perspective, because all the businesses exist to serve the customer. So the first element of performance should be customer oriented. And under customer, of course, under customer perspective, we are looking at aspects of customer satisfaction, aspects of customer complaints. Are they, how many complaints do we have for customers? Look at aspects of customer loyalty and so on. And then we also have what we call internal business processes as one of the other perspective. Now, businesses are also measured on this parameter. And when you look at internal business perspective, internal business process as a perspective, our goal is to look at aspects of how maybe punctuality. How do we serve our customers? How long does it take us? What any kind of delays that we might have. If it's, for example, it's maybe an airport, or it is maybe a company that is in air transport, air company may look at the delays. Okay, if maybe it has delays in terms of its flights and so on. So that would be an area. So business processes look at how fast do you serve your customers. If you're dealing in cakes, how long does it take you to serve a customer who makes an order? 2 to 3 days, hours or so. So that alone can help you be able to measure performance. Remember, if you're looking at different, let's say, subsidiaries or different branches under one group, then you can easily be able to relate, to compare these. When it comes, say, maybe branch A takes you 2 hours, branch B takes you 3 hours to be served, if it's a bank. So that's an issue of business process. We are looking at the business process. And then we also have another perspective that is called learning and growth. We look at learning and growth. And here we are trying to look at innovation. Sometimes we call it innovation and growth, learning and growth. So we are looking at how you've been able to change over time. So this, as a performance measure, it fosters innovation within organizations. If there are branches, the branches will try to continue to innovate, either innovation around reducing costs, either innovations around serving customers, innovation around new products and so on. So we look at the parameters. How has the branch been able to perform at the aspect of innovation? So we can see that we are looking at other perspectives other than financial. A company may have fewer figures in terms of maybe low profits, but when they have been innovative across the whole period. So it means that the innovation will later feed into even their financial performance. And then we also have the other perspective is now the financial perspective. which most of us are aware of. And under financial perspective, you're looking at aspects of profitability. You get looking at profitability margins. You're looking at aspects of costs, okay? Of course, branches, let's say if you're comparing two branches that have low costs are better than those that have high costs. You're looking at things to do with liquidity, looking at things like gearing. So for financials, you may use financial ratios to help you do these dynamics. Now for this question specifically, where they asked us, describe how BCC, the business, this balance scorecard can be used to evaluate skills development and client satisfaction targets. Remember, the skills development and client satisfaction were one of the parameters. They said here that they also plan on the third. She wants to have quarterly targets on both skills development and client satisfaction. So given that perspective, you can be able to respond to this, okay? Basically explain the tool and then be able to provide an evaluation on each of the outcomes. Speak about the aspect of the innovation and growth, the financial performance, the internal business as well, okay? The internal business process, and then finally the financial, okay? But I see that most of these two sections are mostly will come in the aspects of the client satisfaction systems, okay? Because there are so much on that line, then learning and growth. So skills development actually falls under learning and growth. Well, client satisfaction, of course, the client performance, it calls client satisfaction, falls under. We already have that parameter under the BCC. So you can read more about the BCC and see how to relate. Other than that, I wish you a great evening. Bye-bye.
Before you exit, hello, Sam.
Yes.
Before you exit, you had at some point in one of the recordings you shared, you had suggested that you could add us a day in between that it will match with the timetable for more revision, if I got you clearly.
Okay, I did those. I basically maybe just to explain a little.